Hello everyone, welcome to IITM Gate classes. This is lecture 12 on compiler design. And in this lecture, we are going to answer this question, that is every grammar CLR1 or LALR1? So obviously answer will be no. Okay, so while let me give you some example. For example, see, let us suppose we have a state. Okay, and in this state, we have say A implies A dot, B implies A dot. So we are having two final items. And see where final item will be placed in looker heads. So let us suppose looker heads here are A and B, and here looker heads are B and C. So obviously B is common. B is common. So that will create problem for us. So this will be known as RR conflict. If you are having any doubt, let me say this is your state number 5, and this is a production number 1, and this is a production number 2. Now in state number 5, that means fifth row. Okay, and here we are having action part, na A, B, C, dollar, and so on. There will be many terminal symbols in the action part. So what I will say, A implies A dot, that will be placed in A comma B. So here I have to place R1, and here also R1. Now B implies A dot. Okay, so reduce move. Na? So this reduce move will be placed where? In B and C column. In B and C column. So here I have to write R2 and R2. Okay, so this will create problem. So this is known as RR conflict. So you just try to imagine in state number 5, that means fifth row of the table. Okay, this is final item, this is final item. So this is also reduced mode, this is also reduced mode. So where reduced mode will be applied? In look ahead. So in A and B column, we have to place R1, and in B and C column, we have to place R2. So in B column, we have R1 slash R2. That will obviously create problem. So this is known as RR conflict. Okay. Yes. So what about my SR conflict? Okay, so we have two kind of conflict. Now we already know SR and RR. So let me say SR conflict. See here. Say I say A implies A dot and B implies A dot B. Okay, and here look aheads are say B, C, and here look aheads are say A. Okay, so let me write properly. If you are having any doubt, then let me write it properly. So what I will say, see here. A implies A dot, B implies A dot B, and here look aheads are B, C, and here look aheads are say A, D. Now we have to give a move for B here. Okay. So we have to give move for B. So let us suppose the state number is 3, and we are going to new state number 4, and we are not concerned what exactly in the state number 4. Just leave it. We will concentrate here only. So what I will say, this is a reduced move, and this reduced move will be placed where? B and C column. So in the third row of the table, in B and C column, we have to place this. So let us suppose this is R1. So I will, this is production number 1. So I will say R1 and R1. Now I have to give move for B also. From in state number 3, in B column, I have to say S4. I have to say here S4. So that will create problem for us. So this is known as SR conflict. So I hope I have made the point clear to everybody that what is RR whenever two final items and look ahead is same anywhere. What is SR when look ahead of the final item? Okay, when look ahead of the final item is same as the move. Okay, so B move. We are giving B move. Try to concentrate here. We are giving a B move, and B is in look ahead also for the final item. So obviously that will create problem. Okay, so there are two conflicts, RR and SR. Okay, so let me jump to the question and let me show you how they will come. Okay, let me jump to the next slide. So, okay, please pause the video and note it down. Then I'm jumping to next slide now. Yes. So for example, if I say grammar is S goes to A or A goes to A. This is our grammar. So I will try to construct CLR1 and LLR1 parser. So S dash implies dot S. I'm not writing augmented production and so on. I'm just saving the time. S dash implies dot S. Look ahead will be dollar. Now dot is present in beginning of S. So all S productions will be added with dot in the beginning. And their lookouts will be what? These productions are added because of this. So dot will be shifted one position to the right, and we will find the first of remaining part, that is dollar dollar. Now what I will say, dot is present in beginning of A, so I have to add all the A productions with dot in the beginning. And why this production is added? Because of this. So what will be the look ahead of this production? So dot will be shifted one position to the right. We will find the first. It will be dollar only. Now I immediately, my mind will shift it to A, because here we have A and here we have A. So what I will say, S goes to A dot, A goes to A dot. Two final item and look ahead will be same, because in transition look ahead does not change. The same look ahead and final item. So obviously we will be having RR conflict. RR conflict in what? CLR1 also and LALR1 also. Okay, yes, please note it down, and I'm jumping to next slide now. Now I will show you a very beautiful example. Try to follow it. Okay, so the grammar is S goes to A, S or EAC or capital VC or BBA. Okay, and A goes to D and B goes to D. This is our grammar. Okay, and now I will try to construct CLR1 and LALR1 parser for it. So how I will construct? So first, same augmented production. So S dash implies dot S. Dot is present in beginning of S. Okay, and look at will be dollar only. So dot is present in beginning of S. So I will add all the S productions with dot in the beginning. Okay. And this. Now what I will say, why these productions are added? Because of this. So dot will be shifted one position to the right, find the first. So it will be, look ahead will be dollar only. Now what I will say, this dot is present in the beginning of A, so I have to add all the A productions. A goes to dot D, and dot is present in the beginning of B, so I have to add B productions also. B implies dot D. What will be the look aheads? So why A goes to dot D was added? Because of this. So I will shift one dot 1% to the right, find the first. It comes out to be A. Why this production was added? Because of this. So I will shift dot 1% to the right, find the first. It will be C. Okay. So this is small c. Okay. Please do not get confused. This is small c only. Yes. So these are the look aheads. Okay. Now what should I do? Okay. So now let us suppose state number 0. On reading S, where it will go? S dash implies S dot dollar. Okay. This is your accepting state. Say state number 1. On capital A, where it will go? S implies A dot A dollar. On small b, where it will go? It will go S implies B dot AC dollar, and S implies B dot BA dollar. So see here, with B we have two productions now. So we will add them. Okay, so in the same state only. Yes, so since dot is present in the beginning of A, so I have to add all the A productions with dot in the beginning. Now same, I have to add B productions also with dot in the beginning, because dot is present in beginning of B, so I have to add B productions. Now what I will say, what are the look aheads? Why this production is added? Because of this. Dot will be shifted 1% to the right. So here we will get C. Okay, and what we will get here? Okay, what we will get here? B. So dot will be shifted 1% to the right. It will be A. Okay, so I hope I have made the point clear. So this is all about B. Now let us shift to the small b we have done, then capital B. Okay, so on capital B, S goes to B dot C dollar. Yes, that's it. Now on D, A goes to D dot, B goes to D dot, here A and here C. Okay, so there are two final items, but look aheads are different, so no problem at all. Okay, so please do not say that two final items, so it is not CLR1 and so on. Please do not say like this. It will be these only. Okay, because look aheads are different, so no problem at all. So I have read everything here. Now I will read here A dot dollar. I will write here, I will read here capital A. So here we have read this small a. So we have to go here. This is our final item. Now on capital A, S goes to B A dot C dollar. Okay. Now on capital B, S goes to B dot A dollar. On small d, A goes to D dot, B goes to D dot. Again, two final items, but here look aheads are different, so no problem. Okay, for this look ahead will be C, for this look ahead will be A. I think there should be no problem. Yes, so here we will read the C as goes to BC dot dollar. Okay, yes, anything is left? Yes, so here we are C. Yeah, so here we were here. So BAC dot. So it will be S goes to BAC dot dollar. Okay. Yes, so here A S goes to BBA dot dollar. Yes, so now I think everything is completed. Okay, so in GATE exam, they can ask state also. So how many states in CLR1 parser, how many states in LALR1 parser. So just label them, you will get your answer. Okay, so let me label them. So 0, 1, let me label with different color. So this was 0, this was 1, say 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So there will be total 13 states starting from 0 now. So there will be total 13 states in this DL thread. Okay. So this will be for CLR1. Now for LALR1, what we have said, we have to merge the states. So while merging, there can be problem. Okay. For example, and how we will merge according to LR0 item. So see here, LR0 item same. State number 5 and 9, they will be merged. Now, as soon as you merge them, there will be a very big problem. Okay, what will be the problem? See, when 5 and 9 will be merged, 5 is what? A implies D dot A, B implies D dot C, and 9 is A implies D dot C, B implies D dot C. Oh, sorry, D dot A. Yes, so when I will merge them, what I will get, A implies D dot, and here obviously look ahead are A and C, so both will be clubbed now, A or C, and B implies D dot, here look ahead is C and A, so both will be clubbed, so here also A and C. Now we have got the problem. So final item is there, and look aheads are same. So this grammar will be CLR1. This grammar is CLR1, but not LALR. Okay, so please try to follow it. This will be CLR1, but not LALR1. Okay, and this is very beautiful example, and directly indirectly this is the proof that CLR1 parser is more powerful than LALR1 parser, because I have shown you a grammar which is CLR1 but not LALR1. Okay, and merging is creating problem for us. So whenever we do merging in LALR1, then there can be situation like this which can create problem for us. Okay, so please try to follow it. Pause the video and note it down. Okay, let me put everything on one slide. Please pause the video and note it down, and I will jump to the next slide now. Okay, so I am jumping to next slide now. Yes. So that's it. So this is all about your CLR1 and LALR1 parser. And finally, in the summary, what I will say, the most powerful parser is CLR1. Then we have LALR1. Then we have SLR1 and then LR0 according to power. And according to number of states in all these three will be same, but here it can be greater or equal. I have already told you in the previous class. I'm not going to repeat it. Just for the sake of summary, I have given you all these things. Okay. Yes, please try to note it down, and I will jump to the next slide now. Okay, so you may argue with me, sir, why this is the case, that your SLR1 and CLR0 are less powerful than these two? Okay, just let me show you one example. You will get more clarity. Let us suppose, okay, please pause the video, note it down. Yes, now see here. If I say a grammar is S goes to A, B, okay, or B, A goes to null, B goes to null. If you try to remember, we have already proven it that it is not LR0 and it is not SLR1. We have already proven it. Okay, so I'm not going to prove it. Please watch my previous lecture. Now I'm going to show LALR1 and CLR1. Okay, so directly what I want to say is construct LALR1 and CLR1 parser for this grammar. What we will do? So I will say S dash implies dot S. Dot is present in beginning of S, so I will add all the S productions. But what will be the look ahead of this? Look ahead is fixed, that is dollar. Now what I will say, S implies dot A, B. Okay, and then S implies dot B, A. Now why these two productions are added? Because of this. So dot will be shifted one position to the right, and I will file the first. So it will be dollar and dollar. Now dot is present in beginning of A and dot is present in beginning of B. So you have to add all the A as well as B productions. So A productions is only one and B also one. That means null only. So null means what? Nothing. So I have to apply dot here, and these two are final item. Please try to remember it. These two are final item. What will be their look ahead? See here carefully. Now, why this production is added? Because of this. So dot will be shifted one position to the right, and we will find the first. It will be A. Look ahead will be A, and here dot is present in beginning of. Why this production was added? Because of this. So I will shift dot one position to the right and find the first. It will be B. So no problem at all. Okay, in LR0, but we said we have got two final items. Directly I said it is not LR0. In SLR1, we have got two final items, and we have find the fall of A and B. Fall of A and B were A and B. That's why that was creating problem. So it was not SLR1. Okay, now but here there is no problem. This final item will be placed in A column. This will be placed in B column. Okay, so reduce move now. For each final item, we have a reduce move now. So reduce move in A column, reduce move in B column. So there is no problem at all. Yes. So now for S dash implies S dot dollar. For capital A, S goes to A dot A, B and dollar. Okay, for capital B, S goes to B dot B. So now small A goes to A. Sorry, A goes to A, B. Here I have to apply dot dollar. Dot is present in beginning of A. I have to add A productions. Dot in the beginning. What will be the look ahead? Why this production is added? Because of this. Dot will be shifted one position to the right. We will get here B. Now tell me something. On capital A goes to A dot B dollar. And on small b, A goes to A, B dot dollar. That's it. Now come here, small b, B, dot dollar. Sorry, dot is present in beginning of B. I have to add all the B production with dot in the beginning. B implies dot only because B implies null is only production. So what will be the look aheads? Look ahead will be A. Why? Why this production is added? Because of this. Dot will be shifted one position to the right. First will be A only. Now I will read capital B. S goes to B dot A dollar. And finally, I will read A A dot dot. That's it. So see here carefully. Okay, so we have not got any kind of conflict here. Okay, please see this carefully. We have not got any kind of conflict. Okay, and we cannot merge the states. See, this is for CLR1. For LLR1, we have to merge the states, and there will be no merging because LR0 item same but different look ahead. This is not the case here. Okay, so what I will say that this is CLR1 also and LALR1 also. So directly indirectly, I have shown you a grammar which is CLR1 and LALR1, but not LR0 and SLR1. So obviously, these are more powerful parsers. So indirectly, I have proven this fact. And for this question, question can be asked in gate. Number of states in CLR1 and LALR1 will be same, exactly same. CLR1 parser and LALR1 parser. Number of states are same because there is no merging. How many states? You can count yourself. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So number of states will be 10 because we have started from 0. Yes, please note it down carefully. Yes. Now I will jump to the next slide. Okay. So next is LRK grammars. LRK grammars. What is LRK grammar? A grammar is said to be LRK. A grammar is said to be LRK if and only if decision about when to reduce handle to LHS comes after scanning K can be 0, 1, 2 dot symbols after handle is scanned. So this is very, very important point, and this has been asked in gate many times. Okay, in gate as well as UGC-NET many times. So what are LRK grammars? A grammar is said to be LRK if and only if, try to follow it, decision about when to reduce handle to LHS comes after scanning K is equal to 0, 1, 2 dot symbols after handle is scanned. Okay, after scanning the handle, we will reduce this handle to LHS, but when it will be reduced, this decision will be taken after scanning K symbols. So K can be 0, 1, 2, 3, and so on symbols after handle is scanned. So let us suppose, say this is your handle part. Okay, this is entire your handle part. Now after scanning handle, if you immediately reduce it to LHS, okay, let me show you here. For example, say this is your handle. After scanning handle, you immediately reduce it to LHS. That means you are not reading this symbol. You are immediately reducing it to LHS. So that means what you have read 0 symbol. That means without reading any symbol, you are blindly reducing handle to LHS. So it will be LR0. LR1 means what? You have to scan this symbol. LR2 means what? You have to scan two symbols. See, this is your handle. After scanning handle, you will scan two symbols, and then you will take decision that you have to reduce it to LHS or not. Okay, so then it will be LR2 and so on. Okay, so LR2, LR0 grammar, blindly reduction, LR1 grammar, after scanning one symbol, you are taking decision, LR2 after scanning two symbol, you are taking decision, and so on. Now, a very important term is coming. When can I say grammar is LR0? When there exists LR0 parser for it. LR0 parser for it. When can I say grammar is LR1? When there exists LR1, CLR1 parser for it. CLR1 parser for it. Okay. So in GATE exam, if question came, is this grammar LR1 or not? You have to check CLR1 parser for it, because CLR1 is the most powerful parser. Okay. So grammar is LR1 and there is a CLR1 parser for it. Try to follow it. Okay. Yes, please pause the video and note it down. Yes, so that's it. So now our parsers are completed. Okay, I'm jumping to next slide now. And we are going to start syntax directed translations. Our new chapter, syntax directed translations, or SDT. What exactly is SDT? So see here, there are lots of errors which syntax analyzer cannot detect. Okay, so lots of errors are not detected by by syntax analyzer. By syntax analyzer, lots of errors are not detected. Okay, so for example, see syntax analyzer, what type of error it can detect? Like semicolon is missing, opening bracket you have given but closing bracket is missing, and so on. All such kind of error can be detected by syntax analyzer, or you can say parser. Okay, it can detect all such errors. So which errors cannot be detected? So I will give you a very beautiful golden rule. So what is the golden rule? If for any problem you are not able to write context-free grammar, then those errors cannot be detected by syntax analyzer. Okay. So if you are not able to write, CFG, if you are not able to write CFG for any error, then that error won't be detected by syntax analyzer. Okay, so semicolon missing, it can be detected because you can write grammar for it. Okay, very easily. So see, let us suppose I say S goes to E plus T semicolon. Now E will go to something, T will go to something, and so on. Now if semicolon is missing in your string or in your input string, then obviously you will be able to detect it and so on. So I'm not going into that much detail. I'm just showing you the fact that if you think that you can write context-free grammar, then obviously that for that problem or for that error, syntax analyzer can detect it. But there are some error for which we cannot write context-free grammar. Okay, for example, variable is not defined before is used. Okay. Okay, let me do it on the next slide. Please pause the video, note it down. I'll jump into next slide now. Yes. So I'm giving you some examples of error which are not detected by syntax analyzer, like variable is defined before use or not, or you can say variable is not defined before its use. Variable is not defined before its use. This is one of the examples for which you cannot write context-free grammar. Type checking of variables, another example. Type checking. Type checking means like you are doing a plus b, a is of integer type and b is of float variable. So obviously this is a type of error which cannot be detected by your syntax analyzer. Okay, And in case of in C language, if you know C language, then in case of assignment operator, you say x is equal to y plus z, like this now. So you will add y plus z, and that value will be assigned to x. So LHS of assignment operator will be, there should be only one variable. But if you write x plus y is equal to z, then obviously this is wrong. For assignment operator, left hand side there are two variables, which is not allowed. So this kind of error, for this kind of error, syntax analyzer cannot detect it. Okay, we cannot write grammar for it. Okay, or rather, okay, so we can write it if you think that two variables. So let me change it. Okay, actually for it we can write the grammar. Okay, if I say like this, okay, if I say x is equal to y plus z, that is okay. But if I say 5 is equal to y plus z, then it will be not okay, because there should be only one variable. There should be only one variable, but here we have written constant. So variable and constant we cannot differentiate in context-free grammar. Okay, so that will create problem for us. So this kind of errors cannot be detected by syntax analyzer. So hence we need syntax directed translations. Okay, so what exactly SDT do? Let me show you in the next slide. So we will be having syntax tree or parse tree. Syntax tree or parse tree. This will be input to SDT or syntax directed translation, and output will be annotated parse tree. Okay, so syntax tree or parse tree, that is generated by your syntax analyzer, and this will be input to SDT, and SDT will give us annotated parse tree. Annotated means what? Labeled. Okay, so what kind of labeling we are going to do? Let me show you in the next slide. Please pause the video and note it down, and I will jump to the next slide now. Yes. So what kind of labeling? So for example, we have got a parse tree like this: int digit, int digit, and here we have digits. Okay, so we can assign. Okay, so how we have got this parse tree? For example, we will be having a grammar. Say grammar is int goes to int digit. Okay, and digit can be either 0, 1, 2, dot 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 up to 9. Okay, so grammar is int goes to int digit and digit goes to this, and let us suppose our string is 1, 2, 3. So for this string we will generate the parse tree like int goes to int digit, int goes to int digit, int goes to digit. So now this digit will be 1, this will be 2, this will be 3. Okay, so now what kind of labeling? So I'm just giving you example of labeling. So I can say digit dot val is equal to 1. Okay, and here I will say int dot digit is equal to digit dot val. Okay, where I should write, or okay, so like, okay, so let me show you in the shortcut manner. So I will say int dot val is equal to 1, and here I will say digit dot val is equal to 2. Here I will say int dot val is equal to, say, 1 into 10 plus 2. I will say 1 into 10 plus 2, that is 12. And here I will say digit dot val is equal to 3. And here I will say int dot val is equal to 12. Here we have got 12, here we have got 3. So 12 into 10 plus 3, which comes out to be 123. Yes, and here we have 123 only. So how we have calculated the val? So we have got a new attribute, or you can say we have labeled the nodes of the parse tree. See, what we have said, SDT input will be syntax tree and output will be annotated parse tree. Annotated means labeled. So I have done labeling. I have just shown you example. Please do not worry about how we have calculated the values and so on. I'm just giving you example. So for each annotated or labeled, so who will, which thing will be labeled? Obviously, all the nodes of the parse tree. Nodes of the parse tree. Each node of the parse tree will be given some label. So I am giving the label here. So these are the nodes of the parse tree, digit, int, and so on. Let me show you with a circle, then you will get more clarity. These are the nodes of the parse tree. No? These are the nodes. Okay. Now for each node, we have given a label like val. Val is the label or value. So digit dot val is 1. So int dot val is 1. So digit dot val is 2. Okay, because of this 2, we have got 2. So int dot val will be what? This multiplied by 10 plus digit dot val. So digit dot val will be 3 here because of this. So int dot val will be this int multiplied by 10 plus this digit dot val, that is 3. Okay. So I hope I have given you a very small hint or small idea about what are the labels. Okay, so now see, I have done this labeling myself, but how computer will know all these things? So for that, computer we will give some semantic actions. Okay, for example, I will say int goes to int digit. Oh, we have written the grammar, huh? So I will say here I will write the semantic action as int dot val is equal to int dot val multiplied by 10 plus digit dot val. We have done this now. Int, see here, int goes to int digit. So int dot val multiplied by 10 plus digit dot val. So I have written this rule. So int dot val will be int dot val multiplied by 10 plus digit dot val. So this int is this int is this. If you are getting confused, I will write here 1. So here also I will write here 1. So that you do not get confused what is int and what is int and so on. So int 1 dot val, that means this dot val multiplied by 10 plus digit dot val. Okay, that is int dot val. So what about here? So for I will, let me bifurcate it. So I will say digit implies 0, digit implies 1, digit implies 2, dot 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 dot. So digit implies 0 will be what? Digit dot val equal to 0. Here digit dot val is equal to 1, dot 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 dot. Okay. So according to these semantic actions, okay, according to these semantic actions, we have written all these things. So let me put everything on one slide so that you can note it down. Okay, if you are able to follow, then it's fine. But if still you have any doubt, no problem. In the next class, we will start from here only. Okay, and I will show you few more tips and tricks. Okay. Yes. So please try to follow it. Okay. Yes. Or let okay. So I will keep it here till here only. In the next class, we will start or we will resume the lecture from this question only. Okay. And in the next class, we will give you few more questions so that you get more clarity about what exactly is SDT and so on. Okay. So hopefully there will be 2 more lectures on compiler design, and then our subject will be completed. Okay. And let me remind you, this is a basic course. This is not a detailed course. So I will not dig deep into all the things. Yes. Okay. Thank you so much. Bye-bye.